voltage. In electrics, when we talk about voltage, when we talk about current, what are we talking about?
How?
Power. Right. Voltage. It is the pressure, a measure of the electrical pressure. So, right, this one current, it is the flow of electricity or the flow of electrons. Then voltage now, it is the pressure which we need for this to flow. Otherwise, this, without this, this will not flow. Do we understand?
Yeah.
So this one current, it is the flow of electricity or the flow of current. Then voltage is the pressure required to push that, the electricity along a circuit or whatever. Then resistance now, how can I explain resistance? Yes, or think of a water hose. If you squeeze it, what happens? Water is flowing through, which is the current. Then there is pressure, which is forcing the water to flow along the hose. Then if you touch the hose and squeeze it, what happens? We have less water at the outlet. So similarly, resistance is anything that will restrict the movement of current. So these three, they are married. Are we okay then? So voltage, we can have voltage. Okay, what is the unit of measuring voltage? V. Volts. What about current? Amps. And resistance, what is the unit? Ohms. I think that is the symbol for ohms. So that's the basic knowledge we need to know. So, for example, if we have a disconnected battery, a battery which is just there, that battery has got volts at its terminals, but there is no amps or there is no current which is flowing because the battery is just there, it is disconnected. It has got volts but no amps or no current. Then as soon as we connect the battery to a circuit, then we are going to have amps or current flowing. So a disconnected battery has no amps. Just like at the petrol pump, the nozzle. If you don't squeeze the nozzle, it has got pressure already in it. As soon as you squeeze the nozzle, then you get the flow of petrol. So the flow of petrol is the current. So before you touch it, when it is hung on the thing, the petrol thing, it has got volts or it has got pressure in it. So same thing. So we can have voltage, no amps. Are we clear there? But we cannot have amps without voltage. Because amps is the flow of the current. So if there is no pressure, then that current is not going to flow. Clear there? Right, so I'll run through the PowerPoint quickly. So before we go any further, I would like to give you this handout with the electrical symbols. You know, we use symbols for the switches, symbols for diodes, symbol for battery, and so on and so on. So that's the handout. I'm sorry, I forgot to hole punch it. I'll bring the hole punch. I would like to give handouts which are hole punched. Right, electrical symbols, a list of them. Some of them we're going to meet them, some of them maybe not, but keep that handout whenever you do electrics, we'll be referring to it. Right, so we did talk about voltage, we talked about resistance, we talked about current. So a volt, 1 volt, 1 amp, 1 resist. Each time it is 1, 1, 1. So current is whereby 1 amp of current will require 1 volt through a resistance of 1 ohm. So everything will be 1, 1, 1. Same thing with resistance. If we have 1 volt passing through, allowing 1 amp of current to pass through, then we'll have 1 ohm of resistance.
So why do we need resistance in the circuit?
Resistance, if there's rust or if the terminal is not touching properly, there can be resistance.
So do they always match up?
No, they are related. Right, so the relationship between that and that is by Ohm's law, which I'm going to come to in a minute. Right. Please. Right, so I have the handout, don't worry. So like we said, resistance reduces current flow. Then squeeze that as resistance, then we are going to have less current at the end. I did explain that. Then, if the resistance is high, then we have less current flowing or passing through, which is clear on the analog there. Then resistance, 1 ohm, amount of electrical resistance present if 1 amp of current being pushed by 1 volt or a pressure of 1 volt to the circuit. So in all cases it will be 1 unit of each. Right, so resistance, for example, we have that circuit there. Right, so on that circuit there, this symbol here, it represents the battery. Right, so always current will flow from a place of high or more electrons to a place of less electrons. So in this case, this long line there shows that is the battery positive and that is the battery negative. So all the time current will flow that way. That is the fuse, that is the bulb. So if we are going to have that resistance there, that bulb will light dim. It won't be bright because there will be a resistance somewhere. We are not having all the current from the battery flowing through to the circuit. This symbol here, it is showing the switch which is closed. Are we clear there? That is a simple circuit but showing resistance. Okay? Right. Then we did discuss about that, what they are, volts, ohms, and amps. Are we okay with that? So the relationship now between voltage, resistance, and current. I stands for current, and R is resistance, V is the voltage. So the three, they are married. So given whatever we can be given, we can be able to calculate voltage or we can be able to calculate resistance if we have any two of the values. So if I'm going to, let's suppose we would like to calculate the current. Current, we close, then it will be V divided by R. The amount of voltage we have divided by resistance, we get the current flowing through the circuit. If, for example, we want to calculate, so that's the formula there for current. If, for example, we want to calculate resistance, it means it will be V over I. Voltage we have divided by current. Then we get our value for resistance. Similarly, if we want to get our V, it will be current. Sorry. Oh, what have I done? I'm zoomed. How do I? Okay.
Press it and then scroll, and then I'll scroll backwards.
Are you sure? Press it and scroll.
Scroll backwards.
I want to make it small.
I know different.
How do I do it? So voltage now will be current multiplied by resistance. So that is the relationship. A bit of math, but simple. Anybody who is not happy?
You know, you should, yeah, explain
Okay.
the things.
We have some more examples, okay?
Once you know, it's alright. Yeah, it does confuse you, doesn't it?
Right, for example,
It's simple.
All you have to
Right,
remember
for
is
example,
to
right,
VI.
we are given our voltage is 24, right?
Yes.
It's coming-
Sorry, this is level 1.
Yes, it is. You are definitely.
Damn, yeah.
Yeah, okay.
Should I see that?
Right, so for example, we are given voltage 24 there. Then we are told that our resistance is 4. How do we calculate I? So I will be equal to voltage divided by resistance. So this 24 divided by 4, we get the value of the current,
6.
which is 6. So it means for that circuit, we have 6 amps of current flowing. Then we have 24 volts of pressure pushing these 6 amps. Then we have that resistance of 4 ohms. So they are, you see how they are related. Another example, we are given voltage and current. What is resistance?
4.
So it will be voltage divided by current. 12 divided by 3, then we get our resistance 4. Again, another simple. Same thing, we just close what is required, then we get a formula. If it is a circuit now, like that one, 12 volts at the battery, we are having 4 amps of current flowing. What will be the resistance at the bulb?
3.
How much?
3.
3 ohms. So them 3, like I said, they are related, and they are related by Ohm's law. It is called Ohm's law. So that triangle there represents Ohm's law. So you can be able to calculate whatever value you are looking for using the triangle. So you can do the same, you measure with a multimeter, you measure the current there, you measure the voltage, then you want to find the resistance, then you do a simple calculation. Right. The next thing is, no, I'm not doing the power. Right, the next thing now is about the multimeter, which we use to measure. It is called a multimeter because it has got 3 machines or 3 things built into it. It can measure current, it can measure resistance as well as voltage. So it has got a voltmeter, it has got an ammeter to measure current, and it has got an ohmmeter to measure resistance. Right, so you find on the voltmeter, or on the multimeter, we have different poles. So the black one, always it is the negative. The red one, it is the positive. So all the time, the black one, we stick it in the common pot. There are some pots there. So we have the common pot, so the black one stays there. What we play around with is the red one. If it is there, it will be measuring voltage. Then if it is there, it will be measuring current. If it is there as well, it will measure resistance. So you just pull this depending on what you are going to measure. Are we clear there? Right. Then on the ohmmeter, is this clear enough? We have this dial here. Right. So with the dial, I think this will be in your handout. Let me just check if it is there so that you don't need to write anything down. dial now, let's suppose this dial is indicating there. Can you see that V there? Can you see a small V with a wave at the top? The V is like this. This one. So if it is pointing to that, it means alternating voltage. So if you want to measure alternating voltage, you dial this point there. Then there is another V with, is it a dash dash? And it means direct voltage. So this is alternating. Then we have direct. Then if this points to there, it means direct millivolts. Can you see we have a small m and a big V? Direct millivolts. Do you want me to be writing this off?
Are we getting handouts as well? But you want us to
Yeah,
write notes
I'm worried if this is very clear now when we get my.
It's clear, isn't it?
Yeah, it is.
I think you give us the handout.
I think we can do electrician.
Because if I
But all of that's what you're saying that.
Yeah. Right. Then if it is pointing onto that one there,
Yeah, you need to check out your resistance and check the quantity.
it means that is resistance.
So you would have to use it. Yeah, definitely.
Right? Pointing onto this one, small a, what would a mean? With a wave. Alternating current, because A is amps for current. Then we will have an A with dash 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 and a line direct current. So A, remember, is current. Then V, voltage. A wave alternating. Straight line, direct. Then if we're going to have a small m with a big A, milliamps. Small m with a big V, millivolts, and so on and so on. So we have direct current, alternating current, that's the diode symbol, that's resistance, millivolts, direct volt, alternating volt, then on and off. That is what we have on the multimeter. Right. The next thing we are going to look at, let's suppose we want to measure resistance. How do we do it? We want to measure current. How do we do it? We want to measure voltage, simple for simple circuits. How do we do it, and so on. That is what I was explaining. The volts, alternating, direct, ohms, alternating current, and direct, then millivolts, direct. We have that. Right. So now let's suppose we would like to measure what? I'll start with resistance. We want to measure, this is a circuit from our battery through the fuse, through the bulb, we close the switch, then ground. So that's F. So remember, we said this is our negative. Always the negative of the battery is connected to the body of the car, or to any, normally to the body. Then we have our positive, always carrying current to the starter motor, or to the alternator, or wherever. That's the positive. So that is the circuit for a simple bulb. Right, so if we would like to measure resistance, always we have to switch off the circuit. So we switch off the circuit to disconnect it. Then, how we connect the ohmmeter, we can connect the ohmmeter across the bulb. So this always is the positive. Remember, current is coming from the positive of the battery. So the positive will go to the positive. And from there, the current is going to ground. So that's the negative. We connect then we get a reading. Then we know the resistance across the circuit. Are we okay there? We can measure resistance across the switch. Same thing, positive from where the current is coming from, negative, then like this. On the ohmmeter, this on the common, then this on the ohmmeter port. Then we just indicate a reading. This will be on. We have to set the dial to the ohm, where the ohm is. Then we get a reading. Nice. I have this on your handout as well. So you close the switch, then you can measure the resistance. Now, to measure the current which is flowing around the circuit, we are going to leave the black one in the common port. We pull this out, we put it in the ammeter port. It becomes, this unit will become an ammeter. If we pull it, if we put it on the voltage, it becomes a voltmeter. So it changes depending with the position of that. So to measure current now, what you need to do, simple circuit, you measure it in series. Break the wire, then you measure. This is the positive where we have the current flows through there, completes the circuit through there, then you can get a reading. That is measuring current. So always remember to fit the ammeter in series with the circuit. If you are going to fit the ammeter there, there is too much resistance there. That thing will blow. Can you see the? Because this, we have set the ammeter in series, which is fine, which is acceptable. Then, this ammeter is not in series, it is in parallel. So you blow this, because there's too much resistance there. So all the time, never connect an ammeter across a resistance. Break the two wires, then check for current. If it is voltage we are checking for, what is the voltage? Check voltage. If it is voltage now, with voltage, we can connect like that. Voltmeter to F anywhere on the car body. This one, just touch the car body. Then the red one there, positive of the battery. We will get a reading of what we have or what is coming out of the battery. So we can play around with this voltmeter along the circuit and measure the amount of pressure we have. We can put it there, we still measure the pressure we have. So because this is negative, we have no pressure, because this is earthed onto the car body. We can take the voltmeter, change position, put it there, before the fuse, we can still measure the pressure. Change the position of the voltmeter, after the fuse, we can still get a reading. Change position, before the bulb, we still, so it's always the positive. You are just playing about, this one is F all the time on the body. Then you get your readings at several places. That is voltage. Are we clear with that? So ammeter, how do we connect for current?
Which one?
If we're measuring current.
You break the circuit.
Break the
Break the circuit, yes. We do not measure current across like in parallel, right? Then what about resistance? How do we measure resistance?
Between 2 points, we can cut the circuit such you split the circuit.
Yes, make sure that the source of power is switched off, then we can measure.
So you turn off the source of power and then measure across.
Yeah, then you measure on the component.
That's for the resistor, right?
Yeah, just check between the 2 points.
So you go measure the actual component. So
You
that's the volt. You measure just the volt.
Yeah.
Yeah.
Or on the car, the bulb, the light bulb, then you measure.
Yeah.
Yeah. But
So
make
for the
sure
resistor
that-
has to be
make sure
offset.
that the headlamp is off, the switch for the headlamp is off,
Yeah,
then you can
Yeah.
measure the resistance. Are we clear there? So which means if you have maybe let's suppose high resistance, maybe one of your contacts is not touching, or there's too much rust on the or dirt on the contact, so you are losing, there's more resistance. Otherwise you should have very minimal resistance in all cases. So much so that at the end where you want the current or on the bulbs or the headlamps, you have enough current. So if you light the headlamps, they are not bright enough, maybe there's a resistance somewhere. Maybe the wire is not touching properly or ground, it's not earthed properly, so we trace the circuit to see where the problem is. Okay? Right, so next, the last thing, we have 3 types of circuits. We have the series circuit, we have a parallel circuit, and we have a series parallel circuit. So the simple circuits, or how they look like, that is a simple series circuit from the battery, fuse, then down, resistor, then down to earth. An example of a series circuit, the Christmas lights. What happens if one bulb blows?
All the rest of the other colours go
The
out.
whole thing will go. So normally on a car, we do not have series circuits, but we have parallel circuits. Think about the headlamps. If one headlamp blows, the other headlamp will still light. So that is an example of a parallel circuit. If the headlamps or the indicators were made in a circuit which is series, it means if one bulb blew, then no light. The other headlamp will not work. So they are connected in parallel, so much so that one dies, the other one is still working. Then the other circuit will combine the 2, series parallel, which is part of it will be series, then part of it will be parallel. So those are the 3 circuits which we should know how they look like. So at level 1, that is the basic electrics we need to know. This we play around with it a lot in level 3, where we measure the fault finding, because level 3 it involves diagnostics, checking the sensors, checking this. So we play around with that a lot with the multimeter. It's mainly diagnostics. Just about. We all have, so all the checking of the circuits are there, and this series parallel circuits, they are there on the handout. And I think this one, it is all punched. Right, then maybe you need this so that you will understand volts, amps, and resistance. I think enough. What did we do yesterday in the workshop?
Drum brake.
Our brakes.
Exhaust.
This was drum.
And headlights.
Our brakes and headlights.
Exhaust.
And exhaust.
Okay. So far, are we all happy with what we have covered so far?
Yeah.
Hmm?
As long as I'm not this, then I'll be right.
If you read,
Yeah, as long as I'm
did you read last week's one?
yeah.
Right, so like I said this other day, if anything does crop up, if I feel I forgot to mention this, I will just go backwards. Because at times I will think about it. When you are not here, then I'll say, oh, I forgot to mention this or whatever. Right, so the next thing we are going to talk about is the engine. This one. Right, so what we are going to talk about now is we have done all the health and safety and tools, the PPE and whatever. Now we talk about the actual car, the engine. Right, so the engine, we are going to talk about what is known as the four-stroke cycle. Don't mind me. Right, so the four-stroke cycle. Right, so you find it was designed by some geezer called Augustus Otto. It is also known as the Otto cycle. So he was a German. He designed the four-stroke cycle. So you see the dates there. He started the experiments 1864. So the four-stroke cycle has been, or it is the one which is still used by petrol engines. So it is over 100 years old. So many things have changes on the car. Too much electronics, whatever. We've changed the tires, we've changed the shape of the wheels, we've changed this and that, but that four-stroke cycle as it is the one which is being used in the operation of the engine. Everything is just changing, but this, no. Right, so it was invented by somebody from Germany. Right, so for us to be able to understand the four-stroke cycle, we need to familiarize with terminology. Right, maybe if you can just draw the sketch in your show you what I have drawn there. Right, what I have drawn there, if we have an engine, we can have 4 cylinders in an engine, or it can be 6 cylinder, it can be 8 cylinders. Right, what we mean by a cylinder, it is a section like this. So if it is 4 cylinder, we'll be having 1, 2, 3, 4 on a block. Right. Inside the cylinder, we have what is called a piston, which moves up, down, up, down, up, down, up, down, like that. So as long as the engine is running, that piston will be. So depending with the speed of the engine, so will be the speed of the piston, up, down, up, down, up and down. Are we clear there? Right. This piston, this is the piston. This piston is connected to a major shaft in the engine, which is known as the crankshaft. So that's the piston. It is connected by that leg there. We call this leg a connecting rod. So what I have drawn on the board here, it is the cylinder, which is that. This is the piston, which is that. That there is that. Then this is the leg, which is the connecting rod. Are we clear then? Right, so you find as the piston moves up and down inside the cylinder, it will reach a highest point, which is known as TDC. TDC stands for top dead center. TDC, so you see, piston will reach a highest point, that point, we call that point TDC. On its way down, it will reach a lowest point, which is called BDC, bottom dead center. Are we okay there? Right. Then we have the diameter of the cylinder. From there to there, or from there to there. From there to there, diameter of the cylinder. The technical name for diameter of the cylinder, it is called the bore. So I think you've heard people talk about cylinder bore, that is the bore, the diameter of the cylinder. Then next, we have seen that the piston goes up, down, up, down, up, down, as long as the engine is running. The distance moved by the piston from TDC to BDC, or vice versa, we call that distance stroke. So if it moves from TDC to BDC, that distance is called stroke. Or BDC to TDC, it's stroke. So the 4-stroke cycle, it means the piston is going to move 4 times to complete an engine cycle. Are we clear there? Right. Next thing, also, as the piston moves from there to there, it will displace a volume. It will be displacing a volume. So that volume of petrol and air is called swept volume, which is the volume which is swept by the piston from. It will be displacing a volume. And that volume, it consists of air and petrol. So much so that at the end of the day, mathematically, we can calculate volume of one cylinder, right? We get a volume, let's say 60 cc's or whatever. If it is a 4-cylinder engine, if we are going to get volume of one cylinder, we multiply that by 4 cylinders for a 4-cylinder engine, right? Then we will come up with maybe 2 2.4 whatever cubic millimeters. Then those cubic millimeters now they are converted to liters. Then at the end of the day, you will say, I bought a Hyundai Santa Fe, which is a 2.4 liter. I bought a Corsa, which is a 1.6. We mean they are talking about the volume, that swept volume which is displaced for that particular engine. So which means a 2.4 liter engine has got more displacement. A 1.6, yes, that's why we say, oh, I'll go for a 1.4 liter car because it doesn't chew petrol. This one car is tested on petrol, 2.4, it is a big engine. Then a 1.4,
So there's a 2.4
it is not
around.
sorry?
There's a 2.4 move around more than the last one.
Yes, it is tested on petrol.
That moves more.
Yeah, the salt volume, the volume of the cylinders is more. Volume of one cylinder times maybe 4 cylinders.
But is each cylinder the same?
Yeah, they are the same. If it is a 6-cylinder, one volume, cylinder of this times 6. If it is a V8, whatever, volume of one cylinder times the 8 cylinders, then we come up with a figure, which will be in cubic millimeters, cubic centimeters. Then if the cubic centimeters are converted to liters, it becomes capacity. So when we say 1.4 liter car, we are talking about the capacity of this.
We got a handout for this. I pray we do.
Is it too hard?
No, it's not hard, but it's like
It's a lot
it's something we have to read over.
There's a lot to
I
remember.
just have to read over it.
That's one reason why I video.
I can't just
Wait,
take notes of this.
That's why I video.
With the inline engine and the V6
Take
engine,
it,
have
take it.
different amounts of power and stuff.
Yeah,
I
because of
understand.
the capacity. Yeah, V6, V8, which means the cylinders, they are arranged like this. We have 4 there, then 4 the other bank. So it's a big engine.
So you
Then you see 2 exhausts at the back.
Yeah.
Because this bank of cylinders has got its own exhaust. This bank of cylinders, its own exhaust.
You have to know how to measure the volume and all that.
No, I'm just explaining.
So
So I know maths is.
So we have the spec.
But we don't need to actually calculate. the
No,
volume.
I'm just explaining why we say I've got a 1.4 liter car so that we understand what we are talking about.
So if there's
I've got a 1.8 liter car. What do you mean by 1.8, 1.4? What is it? You can be asked that.
If it's got 4 exhausts, it's got 4 cylinders.
If it is what?
If it's got 4 exhausts, has it got 4 cylinders?
No, one exhaust.
So you read all that.
So, right, where we are so far, are we okay? Right, maybe I will need. So what it is, right,
You ever had someone pour out the engine, pour out?
right, at the top,
You can, yeah.
at the top of this,
We pour out someone instead of one. You know what I mean? Yeah. So they use the same cylinder.
this sits on top of the cylinder block, right? Which is the cylinder head. This is the cylinder head. Right, on the cylinder head now, we have valves. Can you see valves? 2 valves for this cylinder, 2 valves for this cylinder, 2 valves for this cylinder, 2 valves for this cylinder. Can we see that? So we have 2, 2, 2, 2. So at the end of the day, we say this engine is a how many valves? Valve 8 valve. Nowadays, we have 16 valve engines, 20 valve engines, 12 valve engines.
Do you always make the same for the intake and the exhaust? Is it
Yeah,
always
so
matched?
in this case we have 2. One valve, we call it an exhaust valve. The other valve is an inlet valve, if we have 2, right? If it is, let's say, a 16 valve engine, we'll be having 4 valves, 4 valves, 4 valves, 4 valves. Maybe 2 valves will be inlet, 2 valves exhaust.
They're always the same, the exhaust and the inlet.
What do you mean say?
Like you wouldn't have like 2 intake and 1 exhaust.
That would be a 12 valve engine. 3, 3, 3, 3.
It is partial.
further about the valves. Right, then on the cylinder head, we also have them ones. They are spark plugs. They are the ones which produce a spark. Right, so I'm going to explain this a bit more. Right, the 4 strokes which we have, why it is called a 4-stroke. We have what is known as the intake, compression, combustion, and exhaust. So those are the 4 strokes. I'm going to explain each stroke at a time. I'm going to explain what happens during the intake stroke. I will explain what happens during the compression stroke. I will explain what happens during there and there. That's the setup, which is like that one. Right, we have our connecting rod, which is the piston leg, that one. That's the piston. Crankshaft, the valves, exhaust valve, and inlet valve. Are we clear there? Right. So what happens during the intake stroke? Remember, this is moving. Right. During the intake stroke, right? During the intake stroke, the piston will be moving down. So when this piston moves down during the intake stroke, it is going to create an area of low pressure inside the cylinder because it's moving down, so a depression is going to be created. At the same time, what happens during the intake stroke is that the intake valve will open. So if the intake valve opens, do we have any valves there? If the intake valve opens, right, we are going to have an inrush of petrol and air going to fill that space. Because as the piston is going down, it is going to create a depression. So that depression now will cause a sucking effect. Then we have petrol and air being drawn into the cylinder until this piston reaches BDC, which is the bottom bit. So by the time the piston reaches there, this cylinder is full of petrol, a mixture of petrol and air. Now, the next stroke now, stroke number 2, remember the piston is at BDC, it starts to go up. During the compression stroke, which is the next stroke, both valves will be closed. That valve closed, this valve closed. Can we see we have the spark plug there? That's our spark plug, which is there on the cylinder head. Right, so when the piston is going up now, because it is now an enclosed space, there's no way for the air to escape, that petrol and the air is going to be compressed. If the petrol and air is going to be compressed, the temperature for the petrol and air will rise. The pressure will also rise. Then what happens when or before this piston reaches TDC, going up, compressing, compressing, compressing. Before it reaches TDC, the spark plug will produce a spark, or it will fire. Then when the spark plug fires, the petrol and the air will start to burn rapidly, then push this piston down, the last stroke. Right, so power stroke, before this piston reaches there, spark plug fires. Right? Now the petrol is going to start to burn. So as it burns, the expanding nature of the burned gases now will force the piston, compression power. Then the piston will start to go up. So as it goes up, that valve opens, exhaust valve. then the burned gases go through there, right out through the exhaust. That is the 4 strokes. First stroke, induction, sucking in petrol and air. Next stroke, compression, compressing the air and petrol. Before the piston reaches the top, spark plug fires, piston is pushed down on the power stroke, then up again, exhausting the burned gases. Because we do not want or we do not need burned gases in there. So they come out through the exhaust. So all engines, petrol engines, 4 stroke.
Every single petrol engine is a 4-stroke.
Okay, let me reinforce this. Sorry.
Every single petrol engine is a 4-stroke.
Sorry.
You said they're all 4-stroke petrol engines.
Yeah, petrol engine. Diesel engine behaves different. I'm going to tell you how a diesel engine behaves. But this is for petrol. So you find after every 2 revolutions of the crankshaft, the spark plug will fire. 2 revolutions, fire. 2 revolutions, spark plug will fire. So we have a spark every 720 degrees of the crankshaft movement. Right, one other thing I forgot to mention, a petrol engine is called SI engine. SI stands for spark ignition. Ignition of the petrol and the air is by a spark from the spark plug. So a petrol engine is also referred to as a spark ignition engine. Right, so what happens is
When that 3.5 straight to the dome.
no sound. Okay. Help.
I think you turned the volume down on the video.
Right? This one.
Down the cylinder until it reaches bottom dead center.
Okay.
This is a cylinder for a 4-stroke petrol or gasoline engine. The first step is to get the air-fuel mixture into the chamber. The mixture enters through an inlet port that is opened and closed by an inlet valve. This is called intake. Next is compression. The piston compresses the air-fuel mixture into a smaller volume. A spark across the electrodes of a spark plug ignites it, and it burns. This burning is called combustion. The burning gases expand rapidly and push the piston down the cylinder until it reaches bottom dead center. The reciprocating action of the piston turns into the rotary motion of the crankshaft. The crankshaft forces the piston back up the cylinder, pushing leftover gases out past an exhaust valve. And everything is back where it started, ready to repeat the whole process. The whole process is a cycle. A new mixture enters and is ignited. Combustion occurs, expanding gases drive the piston down and turn the crankshaft, which pushes the piston back up the cylinder. These 5 events occur in all internal combustion engines. How they happen can change, but they are always there. In one 4-stroke cycle, the crankshaft does 2 revolutions. In those 2 revolutions, how many strokes does the piston make? It makes 4 strokes. Out of those 4 strokes, how many actually produce energy? In one 4-stroke cycle, only 1 stroke out of 4 delivers new energy to turn the crankshaft. What is a stroke? It's the movement of the piston from top dead center to bottom dead center. Calling an engine 4-stroke means its engine cycle has 4 strokes. A 4-stroke gasoline engine uses internal combustion, so those 4 strokes must include the 5 key events common to all internal combustion engines: intake, compression, ignition, power, and exhaust. Let's look at a simplified model. The intake stroke starts with the exhaust valve closed, the inlet valve opening, and the piston at its highest point, top dead center. It starts to move down, increasing the volume above the top of the piston. This makes pressure inside the cylinder lower than pressure outside. This higher outside air pressure forces air-fuel mixture into the cylinder. The piston reaches bottom dead center, the inlet valve closes, and the intake stroke ends. Both valves stay closed as the piston leaves bottom dead center. The piston moves up, squeezing the air-fuel mixture into a smaller and smaller volume, which compresses it. That makes its temperature rise, and that makes combustion easier. Just before the piston reaches top dead center, the next key event occurs: ignition. Burning, expanding gas generates the force to push down the piston. This is the power stroke that drives the engine. The piston now moves from bottom dead center to top dead center. The exhaust valve opens, and the piston pushes out the leftover gases. Let's look at the cycle operating. Intake takes in air-fuel mixture. Compression squeezes the air-fuel mixture into a smaller and smaller volume. Ignition, the mixture under pressure is burned. Power, burning expanding gases push the piston down, creating a power stroke that turns the crankshaft. Exhaust, the piston moves upward, forcing burned gases from the chamber. All 5 events occur in this order in each of the engine cylinders.
So it is a 4-stroke cycle, but we have how many events? 5. The other event is the ignition, when the spark plug produces a spark. Are we clear there? So,
Is that what starts your car up?
sorry?
Is that what starts the car up?
Yes, as soon as you start the car up, that big shaft will start to turn, and the pistons will start.
So when you drive, as soon as you start, that's what it does.
As long as the engine is running, compression, power, exhaust, compression, induction, power, exhaust. So the cylinders, they will be taking turns. The spark plug, this spark plug,
So
they take turns to 5.
So when you start driving, you get faster, it starts getting quicker.
Yeah, as students, the amount of pressure you apply on the accelerator pedal is the faster these pistons move. And the faster the valves open, close, open, close, open, close, open, close. That is why we said the piston is made of what material? Cast iron. Material for piston. Aluminium, light. It has to be light because then the crankshaft still it is heavy. Remember during the power stroke when the piston is pushing down with power, the crankshaft has to be strong, steel, made of steel.
And you say you get 2 revolutions of the crankshaft at every 4 strokes?
Yeah. So every 2 revolutions, spark plug fires. Every 2 revolutions of the crankshaft, spark plug fires. So the cylinders, they take turns to fire. Right. So if the spark plug, maybe there's a fault there, you know there are wires which go there. Maybe one of the wires from the distributor which attached to the spark plug, if it is not connected properly, that engine is going to run on 3 cylinders. The other cylinder is not doing anything. There's no spark. So that petrol and fuel which is going into that cylinder is just a waste. So the engine will run on 3 cylinders. Then we say that car is firing. Or during the compression stroke, when both valves are supposed to be closed tight, maybe one of the valves is not closing properly. So during the compression stroke, when the piston is going up trying to compress or to squeeze the air-fuel mixture, we have some gas coming out through this valve because it's not closed properly. As a result, that engine will lose power. Clear with that?
You say what the say the spark plug goes, you still drive, you will waste more petrol.
If the spark plug is what?
If the spark plug's gone,
Yeah.
it's broken, whatever.
Yeah, if it is broken, if it is gone, the engine can still run, but it will be misfiring, it will run erratically. It won't run smooth. You hear it. Yeah, it won't run smooth, it will run like shaking erratically.
Yeah.
Then it means maybe one cylinder is not firing. One cylinder not firing, it means we are having, remember the petrol, when it goes into the cylinder, it has to be bent. So if the spark plug is not firing, which means that petrol is not going to be burned. If the exhaust valve opens, we are going to get raw fuel coming out through the exhaust and burned fuel, emissions, hydrocarbons.
Oh, is that why?
Then we have our cancers and whatever. It's because of most of the emissions from the car. Just like unburned petrol, just coming out. Something is faulty, maybe the spark plugs, they are not working, whatever. Then we just have unburned fuel coming out, emissions. Right, fake, anybody dying for a fake?
Yeah.